So solving multi-step equations. What would be considered a multi-step equation? Can someone give me an example of what a multi-step equation is? Okay, so an equation where you take multiple steps to solve, meaning what? Can we elaborate on that? What does that mean?
So like one of the problems you gave us, the 3x plus 2 equals 7.
So 3x plus 2 equals 7. So what operations did you have to perform there?
You had two inverse operations and then division.
So you had to do either addition, subtraction, and then your multiplication or division, right? So that's two different steps. What else could a multi-step include? What else have we talked about over the last week that it could include maybe? Okay, it could include exponents, sure. What else? Okay, so we don't need to go through all of PEMDAS, but what else does parentheses include?
Brackets.
No. Okay. When you have parentheses, so if you have something like 2 and then parentheses x plus 5, what is that? Distributive property, so it includes distributive property. It could also include combining like terms, so making sure everything's simplified before we move things from the left to the right of the equal sign. Okay, so that includes everything. We're going to deal with fractions today, like more than what we've seen. But let's just start basic. So if I give us the problem, and this one is kind of what we did yesterday. If I give us the problem 2x plus 7 equals 9. It's multi-step. There's more than one thing to do. And what would I do first? Subtract 7 from both sides. So 2x equals 2. And when I divide by 2, I end up with x equals 1. That's what we did yesterday. So let's add a little bit more multi to that. So negative 6 times negative 7n minus 7 equals 126. And we're going to do this together. Then I'll give you one to try. So what do we see here that we're going to have to deal with? We're going to have to use the distributive property. So if I distribute, I get a positive 42n plus 42 equals 126. Now this equation looks like the first one. Right? I have a variable, I have a constant. I need to get the variable by itself, so what am I going to move?
42.
Okay, so I'm going to subtract 42 because that's the inverse. 42n equals 84. And if I divide by 42, I end up with n equals 2. If you have a calculator, this would be a really good time to take one out. If you don't have a calculator and need one, I would go grab one real quick. I would like you to try this one, please. So please take a second and try that one. If I'm going to distribute negative 5n, I have negative 280 equals negative 40m minus 40. The biggest thing I think here that's going to mess you up are positives and negatives. Okay, so just be careful as you go through. If I add 40 to both sides, I end up with negative 240 equals negative 40m. And when we divide by 40, we get m equals 6. Okay? So let's throw another piece in. We're going to do this one together, so we're throwing another piece into this. What's the additional piece with this problem that we're going to have to deal with? Okay, there's a variable on both sides, so that's different. What else? So we have to distribute, but do you notice the 7 out here?
Yeah.
What is that going to do for us?
Yeah. We have to solve that first and then distribute that number.
So if we simplify this side first, what's that called? I have 7 minus 8x plus 16 equals 31 minus 7x. What are my like terms? On the left-hand side, what are my like terms? 7 and 16. And 7 plus 16 is 23. So 23 minus 8x equals 31 minus 7x. Here's where you get to make some choices, okay? Do I want to put my variable on the left-hand side? Do I not care? Do I want my variable to be positive? Do I care if it's negative? So as you start processing through on how you're going to move, you have to decide what those choices are going to be. As a class, what do we want to do? What are we moving?
Put the variable on the left.
You want to put the variable on the left, so that means we need to move the negative 7x, right? So I'm going to add 7x to both sides. You can't see anything that I just did. That's good. Try again. What the heck? You still can't see it. Hold on. So we're adding 7x to both sides. So I have 23, negative 8 plus 7, negative 1x or negative x equals 31. What moves now? Okay, so subtract 23 from both sides, giving me negative x equals positive 8. And our final step is divide by negative 1, because our variable can't be negative, giving us x equals negative 8. If you chose to move the 8 originally, your variable would have stayed positive, right, instead of having to do that final step. I don't care how you do it, you just have to do it correctly. So you can move things however you want. Okay? All right, let me give you one to try. We have this one and one more, and then we have some fractions. So try this one with your group. Okay. We need to distribute first before we can do anything else. So 189 equals 5 plus 56 plus 64R. My like terms now are 5 and 56. So 189 equals 61 plus 64R. I'm going to subtract 61 from both sides, giving me 128 equals 64R. And then if I divide by 64, you should have ended up with R equals 2. Okay? That's what you got. Awesome. Okay, one last one before we do fractions. And I think I'm going to have you try this one also. Well, let me show it to you and then we'll decide. Do you think you can do that one on your own, or should we do it together? Let you try it. Okay. You are scholars. Here we go. Struggled a little bit on this one. We need to distribute twice. You need to watch your positives and negatives, and you need to make sure you distribute to both terms. Okay, so one thing at a time. Negative 3 times negative 3 is positive 9. Negative 3 times 8x is a negative 24x. Once you distribute, your parentheses go away. Okay, I need to distribute this second set. So 5 times x is a positive 5x. 5 times negative 8 is negative 40. What are my like terms? 9 and negative 40. Okay, if you can't do that in your head, you have a calculator. Literally do what it says. It says 9 minus 40. So if you can't do it in your head, And that's not on, so I should turn it on. 9 minus 40 is negative 31. Okay, so if you have to use the calculator, use the calculator. Negative 24 plus 5 should give you a negative 19x. And that equals negative 50. To get x by itself, what do I need to do? Add 31. Negative 50 plus 31 is negative 19. And that equals negative 19x. And when you divide, you end up with x equals 1. Okay? So one step at a time, watch your positives and negatives, and if you have to use the calculator, use the calculator. Because now we're going to get into fractions. I know. Before you freak out, let's just write it down and talk about it. Okay. So we're going to just write it down, and we're going to talk about this before we do anything. So negative 5/4 x plus 8/5 x minus negative 91 over 80. Everyone loves the look of this problem, right?
Yes.
Love it.
My
Favorite. Okay. So the thing that we love the most is that every single term has a fraction. Right? Okay. Now there's a couple options. If I were going to add fractions, what would I have to have in order to add or subtract fractions? A common denominator. And then I have to multiply stuff and figure out how to add it all together, right? Which I can do. Or, since we love fractions so much, let's just not deal with fractions. Okay? Oh, we're not going to convert to decimals. How can I make those not fractions without making them a decimal? What do I have to do? What did I do on the problems the last couple days? Okay, so I can't multiply by the reciprocal in this one because I would have 3 of them, right? But what I can do, yep, you want to help? So I need to find a denominator that all of them could have in common. Is there a number that I can make 4, 5, and 80? So is there a number that all 3 of those numbers go into?
80.
80? Check. Does 4 go into 80?
20.
Yeah? Does 5 go into 80?
Yeah. 8.
Okay, so if I know that all of them go into 80, and that's my common denominator, that's what I'm going to multiply every single term by to get rid of the fraction. So, okay, watch. Just watch. Before we freak out, let's watch. Here we go. So, we just said, you have to listen. You just said that 80 would be our common denominator. So instead of making them all have a denominator of 80, that number will allow us to get rid of the fractions completely. So if I multiply every single term by 80, okay, let's do that step first. Multiply every single term by 80. Let's see what happens. Ready? This is like 80 over 1, so I can simplify. How many times does 4 go into 80? 20. Negative 5 times 20 is negative 100x. I got rid of the fraction there. What can I simplify on the second fraction? 5 and 80? How many times does 5 go into 80? 16. Okay, so I really just have 8 times 16, which is what? 8 times 16?
32.
No.
128.
128. I no longer have a fraction there. What happens here?
80 cancels out.
They cancel, so I'm just left with 91. Can you solve that problem? Right? I got rid of the fractions. Now I have a basic problem that I can solve. I need to combine like terms to start. Negative 100 plus 128. 28x equals negative 91. And when you divide by 28, what do you end up with? Negative 3.25. Okay? What questions do we have, if any? Does everyone, yeah? Nope, you can leave it just like that. Okay? So it can stay as a decimal. We do not have to rewrite it. Does everyone see how we handled that? Yes. So if we don't like fractions, just like in the last unit, we're going to get rid of them. Okay. I'm going to give you a problem, and I want you to work with your group to get rid of the fractions and to solve. Can we handle that? Okay. Okay. So, negative 1073 over 48 equals negative 19 thirds m plus 3/2 m. So you're going to get rid of the fractions by finding the common denominator. Okay, what number do all three of those numbers go into? So with your group, figure out what that is and see if you can simplify. If we multiply through by 48, and I had a good question. We only multiply, this is really a 48 over 1.
It's frozen.
Ay, ay, ay. Oh.
Oh, that's what I meant. Sorry.
Okay, there it goes. Okay, so really this is 48 over 1, right? So you're looking at two fractions side by side so you can cancel them out. So what happens here? If this is 48 over 1, those cancel, leaving you with negative 1073. So far, so good? Okay. Now, what can I simplify here? 48 and 3? How many times does 3 go into 48? 16. Okay? And then I really have negative 19 times 16, which is negative 304m. Okay, what if the simplifying was confusing? So, real quick, I'm going to write it up here. Shh, listen. If you have negative 19 over 3 times 48, and that simplifying is confusing, multiply and then divide. So, negative 19 times 48 is 912 divided by 3 gives you your negative 304. So if it's easier to multiply across and then divide, do that instead of simplifying first. Okay? What can I simplify here? The 2 with 48, which would give me 24. So my denominator is a 1. 3 times 24 is 72m. Do I have any like terms?
Yes.
Negative 304 plus 72. Negative 232m equals negative 1073. Do you notice how I'm not skipping any steps while I'm doing this? Because that's where you're going to mess up if you mess up. Final step is to divide by negative 232, and you should end up with m equals 4.625. Is 37. Do you have a fancy calculator? Yeah. Same thing. Yeah. Okay, so that's a good question. Do I want you to write the whole number or do I want you to round? If it's like this, where it stops within a few decimals, I would prefer the whole number. If it continues on like 3.6789254, whatever, then that's when we're going to round. Okay? All of these answers, though, that you should get right now should be nicer decimals. They shouldn't be ones that we have to deal with rounding on. Okay, we're going to spend more time doing this tomorrow. I need you to listen. Just because there's fractions doesn't mean we can't deal with it. Fractions will be on your quiz on Thursday, so you need to get used to it. And again, tomorrow this is what we're going to spend time doing. So